Visually solve two variable equations. 2x plus 3y equals 18, x minus 2y equals negative 5. There's two variables in each equation, but you do have two of them. They are different, so you can solve for x and y. I'm going to show you three different ways to do it. The visual method isn't as accurate, but it's less confusing, in my opinion. Start out, this practically begs to use the substitution method. I'm looking there at x minus 2y is equal to negative 5, and I've made room so I can add 2y to both sides and end up with x is equal to 2y minus 5. I can substitute in wherever x is in the first. We end up with 2 times the quantity 2y minus 5 plus 3y equals 18. All I have to do is distribute the 2 and we end up with 4y minus 10 plus 3y is equal to 18. Combine the like terms, we end up with 7y minus 10 is equal to 18. Add 10 to both sides, end up with 7y is equal to 28. And then divide by the coefficient in front of the y to get y is equal to 4. So once I have y is equal to 4, I can my first equation. 3y is going to be equal to 3 times 4 is 12. We add a negative 12 to both sides. We end up with 2x is equal to 6. Divide both sides by the coefficient 2. We end up with x is equal to 3. And here's the second way. It's called the reduced row echelon form, RREF. It's a matrix solution form, and based on the principle that if we multiply every term in a row by the same number, we essentially don't change it any. So what we're going to do is take one of the rows and multiply or divide it by a term so we can add it to the other row and get rid of one of the variables. Taking a look at this one, if we multiply the bottom row by negative 2, and remember you have to do it on both sides, so you distribute, you end up with negative 2x plus 4y when the two negatives multiply together, and a plus 10 when two negatives multiply together. And if we add those together, we're going to end up with 0 plus 7y is equal to 28 on the bottom row. Now we look at, we want to solve for x in the top row, and we have to change the bottom row somehow, so when we add it to the top row, it's going to cancel x. And it may not seem obvious, but if we divide the bottom row by 7 and multiply by 3, we'll end up with 3y. So that's what we're going to do. And we'll end up with 0 plus y is going to be 7 goes in 28, 4 times 3 is 12. 12. And we can subtract that from the top row. We'll end up with 2x plus 0 is equal to 6 and 0 equal to 12. To reduce it and just get a plain x on top and a plain y on the bottom, of course, we're going to have to divide the top row by 2 and the bottom row by 3. If we go ahead and do that, we end up with 1x plus 0 is equal to 3, 0 plus 1y is equal to 4. And if you were doing this on a calculator that had the reduced row echelon form of matrix, you would see this 1, 0 and bar 3 and 0, 1 bar 4, which would mean the same thing as x is equal to 3, y is equal to 4. If you plot it by using the intercept method, you quickly see that the answer is 3, 4, because this happens to work out exact. For the formula 2x plus 3y equals 18, we're going to find the x-intercept by setting y equal to 0. We end up with 2x is equal to 18, x is equal to 9, and we'll plot the point at 9, 0. 2x plus 3y is equal to 18. If we let x equal 0, the 3y is going to be equal to 18. Divide both sides by 3, y is equal to 6. We plot the point 0, 6. Line between them, and we've got our first line. And you can check it out. Check it out at, say, 6. 6 times 2 would be 12. We find our answer is 2 there. 2 times 3 is 6. 12 plus 6 is 18. Your point. Okay, x minus 2y is equal to negative 5. Put a 0 in there, we end up with x is equal to negative 5. We get negative 5, 0, point at negative 5, 0. We set x equal to 0. We end up with negative 2y is equal to negative 5. Divide both sides by negative 2. We end up with y is equal to 2.5. Draw your line, and there we go. Check it at any point you want to. Let's check it at 5. All right, 5 goes in one time, that's 5. And minus 2 times 5 would give us negative 10. Negative 10 and 5 is negative 5, so it checks out. But the main thing to look at is, roughly drawing these graphs, we see the intersection point is at 3, 4. And even if we didn't get an exact answer, that gives us a rough idea that they're both positive and a rough idea what neighborhood they're in. So you can use this to check your answers when you use different ways to get them. Okay, sometimes you won't get an answer. If the two lines are parallel, they will never cross each other by definition. So you won't have an answer. Let's take a look at it. These two equations, the bottom one, the top one, you look at the top one, you say if I divide that by 4, I'm going to end up with negative x plus 2y is equal to 6. And if I add those together, wow, the x's cancel out and we get 0, the y's cancel out and we get 0, and 6 and 4 is equal to 10. 0 does not equal 10. Well, no, there's no solution. Now, if we have two different formulas, but we look at it and we say, gee, the top one, if I divide that by 4, I end up with the same as the bottom one. The lines coincide with each other. We end up with 0 plus 0 is equal to 0 when we subtract the bottom equation with the top equation. And that is true. 0 is equal to 0. And at any x value for one of those lines, it's going to have the same y value because they are the same. Graphing won't give the exact solution in most situations, but it can help eliminate confusion. The intercept method will not work for every situation. For a missing y term, hey, x equals c, for example, 4x equals 8, we end up with x is equal to 2. Well, it's like this. 2 for any y value is what x is going to be. You look up and down. Plug any y value you want in. Here's x is going to be 2. For a missing x term, by equals c, for example, 2y equals 6. So 6 divided by 2 is equal to 3. And this is what it'll look like, x comma 3 for any value. Plug in any y or any x value and it'll be equal to y. Now this general form, ax plus by equals 0. When it equals 0, look at it. The intercept method isn't going to work for us because no matter which one we set to 0, we're going to come out with the same point, 0, 0. Here's a specific example, 3x plus 2y equals 0. Now, since they're equal to 0, this tells us what x and y have to be equal to. They have to be equal to the coefficient in front of the other one, and one of them has to be negative. Look at this. A times b equals ab, and b times minus a will equal minus ab. That'll equal 0. And it doesn't matter if we switch around, we'll get a minus ab in front and a plus ab for a second one. They equal 0. Okay, specific numbers. We end up with 2, negative 3, and negative 2, 3. We have our two. We can go ahead and plot them. And we also have 0, 0, because that's how we can plot it in that case. Let's give you another example to work through. I'm going to use all the methods. Start out. 2x plus 4y equals 8. We set the y equal to 0. We'll end up with 2x is equal to 8 and x is equal to 4. And that's going to be 4, 0 is where we'll plot our point. And the second one, we're looking at, we set x is equal to 0. We'll get 4y is equal to 8. So y is equal to 2. It's going to be our intercept 0, 2. So there we go, 0, 2. And 4, 0. We draw a line through them. Look at this very quickly. Setting y is equal to 0, we'll end up with 3x is equal to negative 9, x is equal to negative 3. And if we set the x equal to 0, we end up with negative y equals negative 9, so y is equal to plus 9. Plot the 2 points, -3, 0 and 0, 9. And if you look where the crossover, solutions are visible in -2 for x and y is equal to 3. Now I'll show you the other two methods. Substitution example. Okay, take a look at it and decide yourself which way you're going to substitute. I'm saying 3x plus 9 is equal to y. Simply added a plus y to both sides and a plus 9 to both sides. Okay, stick in 3x plus 9 in place of y. Distribute the 4. End up with 12x plus 36. And combine the like terms now. We'll end up with 14x. Subtract 36 from both sides. 14x equals minus 28. End up, after you do the division, x is equal to -2. Okay, with x equal to -2, we can substitute in 2 times -2 is -4, plus 4y is equal to 8. Add 4 to both sides, 4y is equal to 12. Divide by 4, we end up with 3. Now we can test the results. Taking a look at the formula, substitute in for x -2 and for y 3. In both cases, when we multiply out and we add the terms together, we can see that we end up with 8 is equal to 8, and minus 9 equals minus 9. So, it's true. Reduce right echelon form. Take a look at the equation. The bottom one, if we multiply through by 4, we end up with 12x minus 4y equals -36. Add them together, we end up with 14x plus 0 is equal to -28. On the bottom, we get 3x minus -9. And now we're going to have to get rid of the x term on the bottom. So we divide the top by 14 first to simplify it, and we end up with 1x plus 0 equals -2. Now, to get rid of the x term on the bottom, we multiply the top by 3 together. We end up with 3x -6. And finally, 1x plus 0 is equal to -2. And 0 plus 1y equals 3. I hope this is helpful. The main reason for graphing anything like this is to see where the answer is pretty much going to be. Even if you can't get the exact answer, it should be helpful.